I should start by saying I almost put the word some in front of challenges for big data in the social sciences. I won't, of course, today claim that this is an exhaustive list of all of the challenges. And I'll just at the outset say we're not going to talk a whole lot about networks today, which is, of course, a huge part of big data in the social sciences. So I hope that some of you got to see Mark's talk yesterday, which was excellent on that subject. One of the really nice things about a conference of this type is that we get to see all of the shared challenges that we face. So in the social sciences, we have many of the challenges in big data that exist in other sciences that we heard about yesterday. So for instance, we have the same sorts of infrastructure challenges, we have the same sorts of munging challenges, privacy protection is a concern. But of interest are the things that are challenges in the social sciences, or at least more emphasized as challenges in the social sciences. And I've been trying to think about, what is the source of this differentiation across the sciences? And one thing that we note is that it's really hard for us to validate our models, right? And part of the reason for this is that we're really primarily interested in explanation or causal inference instead of just pure prediction. And then you combine that with the fact that we generally can't run experiments for every question that we're interested in, and you're in kind of a bad place, right? Okay. And then combine that with the fact that really our big data is of the variety of data's type that we're trying to smush together a bunch of stuff. It's not the massive, massive data sets coming from satellites and so on. It's just, we pick up some government data here, we pick up some other data from over here, we smush it together, and it's a big mess, right? So you combine together those two things, and we have a bit of a problem. And in particular, the main challenge that I'm going to focus on today stems from the fact that proper statistical technique depends on the structure of the data and our assumptions about the data generating process, right? And so what's happened to the social sciences over the last few years is we've gone from particular data structures and data generating processes to very, very new things which push together all sorts of new types of data. Okay, so because of this, we're going to have to develop new methods, right? And for me, this is the thing that is kind of slowing down big data progress in the social sciences the most. It's that you have new data, new structures, new generating processes. You almost have to create a new statistical method for every single problem that you're going to address. So how can we talk about this? Well, it's really hard to talk about this outside of the context of specific examples. So we're going to present a couple of examples from our own work to you today. The first one is about the effects of early in-person voting programs on turnout in elections. Okay? And so the interesting thing for this application is that we now have available to us very granular behavioral data on individuals over time. So after the Help America Vote Act in 2002, we now know for everyone in this room, we can go look up whether or not you voted in the past few elections, right? And we know lots of information about those votes. And we're gonna have to try to figure out how to use that information in our analysis. The second application that Konstantin is going to talk about is trying to measure the influence of interest groups. Right? This has typically been very hard to do. People have done it by case study approaches. What he's going to try to do is put together massive corpuses of bills and model legislation from interest groups and try to see via text reuse how model legislation gets adopted in state legislatures. Okay? And so we're going to talk about some of the statistical challenges we faced in these two applications. And the key point is that essentially we have to invent entirely new statistical techniques to do this. So this is the challenge. Okay, so early voting. What is early voting? So the idea behind, just to be specific, early in-person voting is that, how many people have heard of this? Okay, so I'll go through it in particular. In some states, they've actually extended the voting period so that you can go to polling places and vote not just on election day, but during the couple of weeks before election day. And the general idea behind these programs is that they're supposed to reduce the cost of voting, which should make it easier for people to vote and should increase turnout. Right? That's the general idea. Okay, so how do we go about measuring the effects of these programs in the past? Well, in the past in social science, a lot of our data came from surveys, right? So say the CPS, right? So maybe we have repeated cross-sections. We don't have connections between individuals in 2008 and 2004. We have a different set of individuals in 2008 and 2004. What else do we have? Aggregate government data, so say vote counts at the precinct level. Again, we don't have actual connections between an individual in 1 year and the next year. We have these sorts of snapshots over time. And as a theme today, just to point out, right, so what does this imply for how we go about analyzing the data? Well, this implies that we're probably going to use something like a difference in differences technique. Okay, so just for those of you that don't know what this technique is, I'm just going to go through a quick example of it, and then I'll talk about research that's recently been done that comes to a very counterintuitive result with respect to early voting programs. Okay, so what's difference in differences? So here, I've got an example. Here's a state with early voting in 2008, that's Indiana, and a state without early voting in 2008, that's Missouri. And we're going to start by thinking about comparing turnout rates in those states. Okay. And then we can also look at what happened before the law came into effect in 2004. And so we could look at the comparison between the states when neither state had the early voting program. Now, you might be concerned that maybe Indiana and Missouri are not exactly alike. So, you know, we might control for various things. A simple way to do this might be to say match on things. So just as an illustration, we might match on on counties, right? So here are a couple of counties that we found were pretty well matched on past voting behavior. And so then the idea is basically in the diff and diff design, we're going to compare turnout rate in LaGrange, Indiana to Lincoln, Missouri, right? And then in 2008, after the law has been passed, we'll do the same comparison, but in 2004, before the law has been passed. And then we'll take a look at the difference between those differences, right? And so as long as any remaining incomparability is constant across time, then we're going to be okay with the analysis. This is the traditional approach to asking these questions about the effects of election laws on voter turnout. Okay, so obviously there's an assumption implicit in this. It's often referred to as the parallel trends assumption. Right? And so the idea is basically that the change in turnout in the county that did not have early voting proxies as the counterfactual for the change in the state, in the county that did have the early voting change, right? And the estimated effect is then the vertical distance between the top of this solid line and this dashed line here. Okay, so this was the state of the art pre-big data, right? This is all we could really do with the data that we had. And in fact, very recently, a team of researchers at Wisconsin did just this. They tried to look at the effects of early voting programs on turnout across the United States, and they came to a rather surprising result. And so I don't know if you can read this here highlighted, but basically they found that the evidence says that early voting programs actually decrease turnout. So that's kind of interesting, right? We would think that early voting programs would reduce costs and increase turnout. They're finding the opposite. And they have an explanation for this. They say that basically these programs extend the election period and they lessen the intensity of mobilization efforts on election day. That's their explanation for what they're getting. Okay? Now you might think a counterintuitive result published in a political science journal, even though this is the #2 political science journal, this is going to be ignored by everyone, right? No, it's not. So here's the Secretary of State of New Hampshire who is saying that he's opposed to adopting early voting programs on the basis of essentially this evidence. So, you know, this is a finding that is having a real effect in the world, and we'd like to know, is it right? Okay, so there are two essential criticisms of this finding. The first is, of course, that there could be a failure in the parallel trends assumption. Right? You could have changes in comparability across time, and ballots are one way that could happen. Ballots change across states, across time. But the other criticism was really more of a big data criticism, right? It was, wait a second, we have all this new data, and you're not using it, right? In particular, we know for each individual in those states whether or not they voted in those elections, each one, and what mode of voting they used in each election. So we can tell that somebody voted on election day in 2004, but voted using the early in-person or EIP program in 2008. And intuitively, that has to give us information, right, using voting mode. Unfortunately, it's hard to put it in the analysis, right? And this was what took all the work for us. Okay. So what are the challenges in using voter history files? Well, the problem is that voting mode, whether you vote on election day or whether you vote absentee or whether you vote early in person, that's very kind of tied into the outcome variable of voting generally, right? And so, you know, in the biz, we call this a post-treatment variable. It's generally difficult to include post-treatment variables in a causal analysis or in a program evaluation. So how do we start to think about doing this? Well, the advocacy approach, so what would a group that says we love early voting programs, what would they say? Well, wait a second. If people are using these programs, isn't that evidence that the program is having an effect on turnout, right? And so they might estimate the effect as the proportion of people in 2008 that are actually using the program. So what's the problem with that, right? It assumes that essentially those people would not have been able to vote by other means if the program had not been available. Okay. So maybe we can do a little better than that. Right? So first, we might subset to groups of individuals for whom we think the program might have an effect. Right? So maybe people who previously had used the program or people who had previously not voted. I'm not going to deal with the previous non-voters today just because the data is really messy on them. That's another challenge that we're working on. But that's the idea, is subset to the people that previously used the program, leave out people that previously voted absentee ballot, since we might assume that they're capable of voting again by absentee ballot if the program's not available. Okay. So we're going to subset by previous voting mode. Okay. Second step, we might try to account for substitution. So even those people might have substituted into another mode if the EIP program had not been available in 2008. So what we might look at is the following. What percentage of people who voted EIP in 2004 managed to vote by other mode in 2008? And we can think, okay, maybe that tells us something about the substitution rate, right? You might worry at this point that we're still kind of just in ad hoc land, right? Just making this up as we go along. What we were able to do in this paper, though, was to show that essentially this is equivalent to something called a front door estimator. And a front door estimator is an estimation technique that was developed by a computer scientist named Udaya Pearl in 1995. And it's an interesting idea, but it hasn't been used all that often. But it basically gives us a means of including these sorts of post-treatment variables in an analysis. So here's kind of the key step, right? You have this data. Intuitively, we think this should bear on the problem. We can't use traditional techniques. We had to go out and find some random technique somewhere that would allow us to do this. And that took a lot of effort. Okay. It's still not great, and you can kind of see this. It's still, if you look at this, it's just a multiplication of two proportions. So for instance, we can't get a negative number out of it, so that's not good. It's bounded below by 0. Also, the connection to the front door literature allows us to look in the paper, and we can show that probably this thing has positive bias. So we took it one step further, which is we want to adjust for that bias by looking for a differencing group, or a group for which we think there should be no effect. Previously stated, we think that previous absentee voters should not have an effect. And so we can adjust by them. Okay. And then final step is we have another group that we think the program should not really affect so much. And these are people who managed to vote on election day in 2004. Right? And so we can rerun the analysis for them with the understanding that we should get a 0 effect for them. Okay. People who voted on election day in 2004, maybe something happened they couldn't vote on election day in 2008, but for the most part, we think they're going to be able to do it. Okay. And so we developed an estimator that allows us to do that. Okay. And there's the placebo test using election day voters, and then here are the results. So On the left here, we have our estimated effect for people who previously used the EIP program. So what do we assume the effect is in 2008 for them? And on the right, we have, this is the placebo test. This is our estimated effect for people who previously used election day voting. Right, so we assume that this effect should be close to zero. And this red dashed line is the zero. Right, and so what we see is that our placebo test is passing. We're not seeing evidence of an effect for the placebo group. And we're getting a positive effect, about 1.5% for the group for which we think we should find an effect. Right? And so I should say, just in terms of scope, this is just Florida. Part of the challenges of big data within this project is that state to state, there are differences in how this data has been reported and stored, and it takes a ton of effort to go out to all these places and get all of this information. But if you can step through all of these challenges, it looks like we're bringing some information to bear on this problem that at least is different than what was brought by the Wisconsin team. So at this point, I want to hand over to Konstantin, and he'll talk about another example with different data and different challenges.
All right, so I'm going to talk to you about interest group influence. So this is a different application, unrelated to early voting, but also one that I've been working on with a colleague from Harvard. So let's start in 2006. There's a bill that appears in Florida, and I know you can't read the text, but there's a bill that appears in Florida that creates something called the Council for Efficient Government. And this is a commission that it annually meets and decides government services that should be privatized, recommends government services for privatization, okay? What's interesting about this is not the actual content of the bill, but the fact that in 2010, in Virginia, the same language appears in their introduced bill, okay? Again, they call for the creation of the Council for Efficient Government. And in 2011, the same thing is introduced in Kansas. So one might think that this is state legislators sort of learning from each other. But in fact, after digging around, what we find is that there's an interest group called the American Legislative Exchange Council, or ALEC, that creates model legislation and disseminates them to state legislators for implementation. Okay? So this is a screenshot of their website that shows the model legislation for this Council on Efficient Government. So what is ALEC? Just give you a very brief background. It is, in their own words, the nation's largest nonpartisan individual public-private membership association of state legislators. It was founded in 1973 by conservative political leaders. It comprises nearly 2,000 state legislators. Just to give you a sense of how many that is, that's around 1/3 of all state legislators, so that's pretty substantial. And around 200 private sector firms, including many Fortune 500 corporations. And the activity that, one of the activities that ALEC engages in, which is going to be relevant for this project, is that they produce and disseminate model legislation. And more broadly, they produce and disseminate policy ideas. And specifically, the way that works within ALEC is that usually business joins ALEC, and business has certain interest in specific policies, and they come to ALEC and they say, this is what I want enacted, or this is the policy I prefer. And ALEC writes model legislation, and they have this network of state legislators that then they're able to go to with this model legislation. More broadly, they also provide research assistance and expertise to state legislators. So I'm using ALEC as an example. It is one of many, many different groups across the political spectrum that operate in the American political system that try to influence American politics, right? That try to influence legislation. And this process of influencing legislation has been of tremendous interest to political scientists historically. This is a literature that sort of started, one of the literatures that was really there at the beginning of political science. very vast literature in the 1950s and 60s of all these people asking questions about who really makes the decisions in our political process, who has power, who influences legislation, who influences policy outcomes, right? So political scientists care a lot about this. Traditionally, as Adam mentioned, we have not really been able to answer this question well, partially because the data is just not readily available, right? This is a very hard problem to answer. In the past, whatever empirical work has been done by case study. So usually looking in depth at one particular organization or one particular law, but there's been very little systematic analysis. And so what we're doing in this project is that we're trying to change that. We're trying to use new forms of data that have now become available to try to answer this question, or at least to begin to answer this question. And the data that we're going to use is the text of all state legislation for the last 2 decades or so, from 1995 to 2013, across all 50 American states. It comprises around 2.4 million bills. So this has never been collected before. And then text of interest group model legislation. And the idea is, kind of simply speaking, as Adam also alluded to, is we're going to try to find footprints of interest groups from their model legislation in actual laws that are introduced and enacted across American states. And this is, really has the potential to change our ability to answer this question of influence. I should mention that this is work with Alex Hurdle-Fernandez, who's also at Harvard. So yeah, just giving him credit also for a lot of this. So the empirical puzzle, just to recap, and I'm going to talk, I sort of set the stage for you with what political scientists are interested in terms of interest group activity, but the specific empirical puzzle we're going to address in this paper is where does ALEC succeed? So we're going to be interested in what types of states and what types of legislators are going to be more likely to introduce and or enact legislation from ALEC. Or one way to put it is legislation that is authored and promoted by business interests, okay? Now, the challenges in the project, aside from actually going out and collecting 2.4 million bills that come from very diverse sources, and you have to clean them because they usually come in PDFs, right? So it's a big challenge to actually assemble all that. But I really want to focus on the more statistical challenges in this project. So even with this new data, right, identification of interest group influence is really, really, really hard. It requires a whole range of new methods for extracting deeper structure of text that we just we don't have, right? Specifically, what makes it so challenging is that language is complex. There are many ways that you can say the exact same thing, right? You can mean the exact same thing, but you can phrase it in many, many different ways. And to pick up on that, you need methods that are that take that into account. And so specifically, you need methods that sort of begin to, you have to really conceptualize what generates this data, what generates this text, right? As Adam mentioned, a big challenge of big data in social sciences is understanding the data generating process and being able to find a statistical technique that is appropriate for that process. And that's certainly the case here. Validation, more generally, is extremely crucial. You have to make sure with this data that what you're getting out sort of makes sense. You have to try to benchmark it to existing knowledge. And another challenge is disentangling causality is extremely difficult with this data, right? If you see two states that adopt the same piece of legislation, how do you know which one came first if they were both enacted in the same year or introduced in the same year, right? So you have to be very clever about leveraging external information, trying to model the process by which bills or bills are introduced, bills are enacted, and the way that language diffuses. And that's really, really hard. So just to show you, I'm not going to go into the methods, but just to show you why it's hard. So first to show you a case where it's not so hard, and then a case where it's hard. So a case where it's not so hard is the same bill for Council for Efficient Government in Virginia in 2010. And this is just an excerpt of 2 paragraphs from that text. You don't have to read it, but this is the Council on Efficient Government proposal from ALEC. And all I'm going to do is just highlight the differences in the 2 texts in orange. And you can see that they're pretty much copy and pastes of one another. So this is super easy to, well, not super easy, but relatively easy to detect. If you run it through any sort of plagiarism detection software, this will get picked up. What's much harder and requires a rethinking of the existing methods and sort of deeper modeling of language is this example here. So this is another bill from Virginia in 2010. This one is a bill that proposes to defang the individual mandate in Obamacare. And this is the ALEC model legislation. Now, in this case, we know from extensive media reporting, et cetera, that the Virginia bill was influenced by the ALEC proposal. But reading the 2 texts, right, they're very short. This is actually the extent of the 2 bills. There's nothing else. You would not necessarily, this is hard to detect because the language is not shared. There are very few consecutive words. In fact, there are only 2 words that are stringed together that are shared. There are no sequences of shared language. So you need to start to think about deeper meaning of language. You have to go beyond lexical similarity, and you have to start thinking about semantic similarity. So we have some preliminary results that we're still tweaking. This is an ongoing project, but we did try to identify sort of the distribution of introduced ALEC legislation across the American states in this time period in the last 2 decades or so. And this is the result. So states that are darker red have introduced more ALEC legislation. One nice thing about this map is that it sort of corroborates what we know sort of from qualitative work on ALEC, that it is extremely active in West Virginia, Missouri, and Arizona. So that's good. That's a sanity check. And this is why it's important to validate your data, because you could be getting out something that makes no sense. So what we can do now is we can begin to ask, okay, this is interesting, right? So we have some variation. This might be interesting to policymakers. This might be interesting to activists. But political scientists, we want to really understand what causes this variation, right? As Adam mentioned, we care a lot more about explanation than we necessarily do about prediction in many cases. It's not always true, but so in this case, we care about explaining this variation. So let's take West Virginia, right? So it's the state that has the most introduced ALEC legislation in this time period. Why West Virginia, right? Well, one hypothesis is that it is not a very professionalized legislature. That is, the legislators who actually work in West Virginia only meet for 2 to 3 months of the whole year. They get paid $20,000 per year, and they have extremely few staff. So that might make them more likely to rely upon external sources, external resources, such as model legislation from ALEC, for their legislative proposals, right? If you only meet for 2 to 3 months in a year and you're paid $20,000, you're not likely to invest a whole lot of time into drafting legislation. And so the hypothesis is that lower legislative capacity, so legislative capacity being some sort of aggregate index of all these different things that I've mentioned, will lead to legislators being more likely to introduce and/or enact ALEC drafted legislation. Now, West Virginia obviously is distinct from other states in other ways, right? So they're coal states, so that's huge there. They're clearly different in that respect. And ALEC has some bills that promote coal. So maybe that's why they're maybe that's why they have so many introduced ALEC bills. Well, so what we did is a much, much more systematic analysis of variation across all states and across time, right? So we did a panel data set of ALEC introductions and enactments, and we controlled for a bunch of different characteristics of states. So we controlled for partisanship and campaign spending in states, things like that, things that you might think influence a state's decision to the state's use of ALEC bills. And what we find, so this is a result that shows you where on the x-axis legislative professionalism goes from the minimum observed value to the maximum. So you can think of the minimum being states like West Virginia. On the max, you have states like California and Massachusetts that have very professionalized legislatures that are paid extremely well and that are in session almost all of the year. And on the y-axis, you have the estimated number of ALEC bill enactments. And what you see is that you go from around, in the states with the minimal professionalization, you have around 4 ALEC bills enacted per year. And then you go to almost 0 as you go to the states that have maximal professionalization. Okay, so this is an initial result from our work, and this is very interesting to political scientists because we sort of want to understand what are the factors that determine when interest groups much more generally have power in the political process. So this is ongoing work, as I mentioned. This is just looking at ALEC was one particular example. We are doing something much, much broader. So we're moving towards an individual legislator analysis, which involves taking this text data and and actually merging it with other data sets on individual legislators. So we can sort of gather information about, we know who these people are, right? We know who all these people are. We can gather tons of information. It's hard because it's not centralized, but it's doable, right? With enough time and resources. So we can actually begin to understand who are these people and what influences their choice of relying on model legislation, for example. And we're also interested in looking at diffusion of laws more generally between states. So we believe that there are underlying latent networks of legislators. We can't really observe them, but we think that legislators are sort of meeting up at there are conferences, nationwide conferences, where legislators meet, they talk to one another. And so we think that there are these underlying latent networks of legislators by which policy ideas spread. And again, this has been of interest to political scientists theoretically. We've never been able to actually look at this. And now we can, because we have a corpus of 2.4 million bills for all 50 states for the last 2 decades. So this is really powerful and really gives us the ability to start to answer these questions. What's really hard about this, again, going back to the point that we need to think about the data generating process, is that there are a ton of different components in this data, right? We have text, we have these underlying latent networks that we are interested in. So I mentioned text. We have time, we have a time dimension to all of this, right? So how does time interact with this network? We have geography, right? And we have more things than that, right? It's just an example of all the different data that we can pull together. And you can't just throw it in and expect to get something interesting out, right? You have to really conceptualize the data generating process, be clear about your quantities of interest, and spend a lot of time designing new models, because this stuff doesn't exist already. So that's really what takes up the most time. And that's really what extracts the value from big data in the social sciences. Just having this data isn't really that valuable by itself, right? What's really valuable is the ability to sit down and think about what generated that data, using statistics to write down a model, and trying to estimate substantive quantities of interest. That's what extracts value from big data in political science and in social sciences more broadly. So on that note, just to conclude, in the social sciences, big data, as we've shown you, is often it's not defined by its size, right? We don't have anything on the scale of Google, but it's really defined by its variety. It comes from so many different sources. So we have, as Adam presented, we have individual electoral data. We have unstructured text data, as I showed you with this corpus of state legislation. We have networks in some cases. We have geographic data. We might have web queries. And all of these things can be merged together. But the problem is when you start doing that, you have to start thinking really hard about statistics and you have to start developing new statistical techniques in order for this data to be useful at all. Okay? And that's it. So thanks.